It is now going. All right. So I am hoping that all of you got a chance to watch the video that was recorded on Monday because I'm assuming that you did when I planned for today's lecture. So I think it's fair, okay, because you already knew that I have an in-person lecture on Monday and it is recorded on YouTube. And this is how we can keep the pace of this class so that you learn enough so that you'll be ready for CISP 360. So if you have not watched the video on Monday, I encourage you to watch that as early as possible so that you don't fall too far behind because it is very easy to fall behind in any one of my classes. Some of you will be taking additional classes from me in the future. So this is just uh, it's a statement that is applicable to all of my classes. All right. So with that said, the record is on already. So everything from here on is going to be recorded. First thing first, on October 1st, we are going to have our exam one, a version of exam one from spring 2025 is already attached. So that means, you have an opportunity to take a look at it for 2 whole weeks before your actual exam one. Okay, so what is your plan? What is your plan? I would do this as soon as possible. Why? Because next Monday, on the 22nd of this September, I will be talking about it. Okay, so the question is, why do you want to have a chance to look at it and give it a try before I talk about it on next Monday? Why? So that you can assess how well you can answer the questions before I talk about it, because that would be a authentic assessment of where you are at. Okay, so if you're going like, okay, I cannot answer these questions, then what do? You have to play catch up. On the other hand, if you go like, oh, these are easy questions, I can handle all of these, and then on Monday I talk about it, and you guys go like, okay, this is exactly what I have written down as my answer, then you have some confirmation that you are doing fairly well in the class. So I think it is a good idea to take a look at these before Monday, before I talk to before I talk about it on the 22nd of September. But once again, it is up to you guys to decide how you want to spend your time. So that's basically something that for you guys to consider. And then for today, this is the agenda. So the agenda for today is first to review the answer to the homework assignment. And then the second one is to give you the new homework assignment. And then we'll present another example of nested statements, which I already have prepared down here. And then I'll ask you guys about the AI policy, as an institution. What do you think the school, the college should adopt as an AI policy that's going to work for you? And in fact, let's go ahead and start with this one. Okay. So I'm pretty sure this is not the only class you're taking at ARC. So do your other classes have any kind of AI policy or policy related to the use of AI? I'll let you guys. Yep, go ahead. Okay. So, but do they let you, but they cannot restrict you from using AI when you're studying. So that's okay. 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 Uh, okay. So they don't check it. They say they do. Okay. All right. All right. So if somebody, is to turn in any homework that is AI generated, or at least the professor thinks it is AI generated, what's going to happen? Okay. Uh-huh. Uh-huh. Okay. All right. Anyone else? Any policy from English writing classes? Because I know the English department is kind of divided on this issue. Yep, go ahead. Yeah. Hmm. Okay. Okay. And what if, the submitted work has components that the professor thinks is AI generated? What's going to happen then? Oh, okay. All right. Anyone else? No. All right. Well, for this class, we're going to have exam one in person. I'll give you the actual paper, and you'll be doing everything on the paper using your finest writing instrument. Okay. Number two, pencil usually works fairly well. And no electronics when you are, doing when you're answering the exam. So that is my policy. Okay. Is it anti-AI? Is it pro-AI? I think it depends, right? Because I gave you the GPT-TA, okay? That's something that I have provided. But at the same time, when I'm doing the assessment, I want you to tell me how much you know about the content of this class. So that's kind of my policy, okay? Um, do we have any questions about the AI policy for this specific class? So I cannot speak for any other professor, whether it is good or bad to use AI in the learning process. But in this class, I will give you the tools, that I think is helpful. You can choose not to use it. You can choose to use it. But when we have the exam, it is not going to be, it's not going to involve any electronics. Okay. If you want to bring a calculator, that's fine. Even with a TI graphing calculator, that's okay too. But we are not going to have tablets or laptop computers. All of these computers in the classroom will be down. Okay. So you're not going to be using any computer during the exam. Are we good so far? That being said, it is also open book and open notes. So that means, you have 2 weeks, okay? If you have not been doing it, okay, you can start today and prepare for all the stuff that you can bring with you on the day of the exam, which is the 1st of October. And you can bring as much as you want. There's no restriction. I know some professors, say, okay, 1 page of material. In this class, it is unlimited. Okay, as long as the material is on some form of dead tree, it is going to be okay. Is that okay? So yes, I'm not very environmental because I encourage people to bring parts of a dead tree to the exam. Are we good so far? Okay. All right. So with that all said, we are going to take a look at the homework assignment that was due earlier today, like 9 minutes ago. So that's what we'll do first, and then we'll move on to other things. But I'm keeping this page on, just so that I can refer to it. All right, so the homework assignment that you guys did was about conditional statements, and the homework is right here. All right, so do you guys want me to kind of show you what it looks like, as the answer, or you guys go like, no, no, we got it already. Show it? Okay, all right, that's what we'll do. All right, so this one requires you to do it using a Google Sheet. Okay, so I saw a lot of notifications of people sharing their Google Sheets with me. That's good. Okay. And what we'll do is we're going to go to the um, shared folder, and I'll create a document with today's date. So that way you guys can go like, oh, okay, that's what we talked about today. So I have to go to the shared folder and then create a Google Sheets and then name it with today's date, 2025-09-17. And now we go back to my homework assignment. Okay, so I'm going to read the homework assignment. Refer to the find max 3 algorithm in back to the example. So this would be the first thing that I do. Okay, open up the module and go back to the example. It goes straight to the example. So this is the code that you have to trace. What I do is not something that you need to do because I have limited resolution on this screen. So this is what I need to do to keep it in context. So I'm going to put it here. And then what I'll do is go back to the homework assignment and find out what else do I need to do. So make three sheets or three tabs in the spreadsheet, one for each of the following cases. W is the maximum, X is the maximum, and Y is the maximum, and name the sheets accordingly. Okay, so that's what I'll do. I go here and name this one W, create another one, name this one X, and create another one and name this one Y. All right, go back to my instructions. There's no need to create an additional sheet for the algorithm itself since it is applied. So that means this is already in the teaching material. So there's no need to create a sheet just to show the algorithm itself. In each sheet, trace the algorithm as demonstrated in the section linked at the beginning of this assignment description. Do not reuse any test cases that are either in the reading material or used in the lecture. The scoring is based on the formatting and also the correctness and so on. All right, so that's what we'll do. The first one, okay, so I'm going to go back here. The first one needs W to be the maximum. So I already know the format of the trace. I need line number to use one column. I have one column for each variable. In this case, there are four variables. There's W, there's X, there's Y, there's also Z. And I also need one column for comments because every time we evaluate conditions, we have to indicate whether the condition is true or not. So that's why we have these five columns for all three sheets. I'm being lazy because I just copy and paste these five to every single sheet in this document. There we go. Because they all need these columns. Okay, but what is in the column can be different. This is the precondition. For this one, I need W to be the maximum. So there are a few ways to make it the maximum. I can just say, okay, let's make this a 6, and these two would be 2 and 3. This starts with unknown, and then we proceed from there. So on line 1, in this case, W is greater than or equal to X, and W is greater than or equal to Y. Each one is true. I typed it incorrectly because it has to be greater than or equal to, but not the other way around. So this is true. So you can spell out true. You can say 1. You can say T. As long as I understand it means true, it's going to be okay. So where do we go when the condition of line 1 is true? Line 2, that is correct. So we go to line 2. Line 2 has one thing to do. It is an assignment statement. So we take the value of the right-hand side of the equal, which is just W. W currently has a value of 6. We take that value and then we use it to update whatever variable is specified on the left-hand side, which is Z. So Z is updated to the same value, which is 6. And now I'm done with line 2. Where do we go now? Post. Very good. Okay, so we go to post right away because that is how this code is structured. All right, so that's one sheet. Okay, we're done with this one. Now we go to the next one where I need X to be the maximum. So once again, we have a precondition and you can make it kind of fancy if you want to. So you can make X and Y being the same. That would still work. Okay, so you can make this 45 or 45. This one is also 45 and this one is -6. Okay, Z can be unknown. So now we go to line 1. And the condition of line 1 is W is greater than or equal to X. Is that true? It is false. Very good. So we can actually conclude right away and say this is false. And that's all we need to do. Okay, now if you finish the entire expression and say the entire expression is false, that's good too. But why can't I shortcut the whole thing and say, oh, this is false and I know where to go now? Hmm? But why can I simplify the expression and not to evaluate the right-hand side of the conjunction? That is correct. Okay, so we can shortcut it. It is also known as, either you can call that the lazy evaluation. It is also called the, short-circuited evaluation of a conjunction. Okay, so with that being false, where do we go next? Line 3, that is correct. Okay, we do not go to line 2, we go to line 3, which is also having a condition to evaluate. This time it is asking x is greater than or equal to w. That is true. But can I conclude right away that the conjunction is true, knowing only that x is greater than or equal to w? I cannot make a conclusion because you need both sides of a conjunction to be true for the whole thing to be true. So I actually have to evaluate the other side too, which also turns out to be true. X is greater than or equal to y is also true because they are the same. Okay, because when x and y are the same, have saying one is greater than or equal to the other one is still true. So the whole thing is true now. And then where do we go? Line 4 is correct. So on line 4, we are updating z using x as the expression on the right-hand side. So that means your z is now getting the value of 45. And then we are done. We go to post, and that's our second trace. Oops, hoist, post. There we go. So the last one is about y. Okay, we need y to be the maximum. So the precondition is, okay, somehow we have to make y the maximum. I can be a little tricky, make this -3, and then the other ones are even more negative. Okay, that'll work. And we go to line 1, and the comment is w is greater than or equal to x is already false, so we can come to the conclusion that the entire conjunction of line 1 is going to be false. Okay, cool. Then we go to line 3, kind of the same thing because we can look at the left-hand side of the conjunction, which is just asking, is x greater than or equal to w? X is greater than or equal to w is false. Okay, is it false? Yep, it is false. So we can now decide right away to go to, now I would not go to line 5, but if you write down line 5 and then line 6, it's okay. Okay, but I do not use line 5 because line 5 is nothing more than a symbolic breakpoint between the then case versus the else case. There's nothing to do other than, oh, okay, we have to go to line 6. So if you don't trace line 5, it is correct. Okay, but if you do say line 5 and then line 6, I'm not going to take any points off. Are we good so far? Does everybody understand why line 5 is not necessary in the trace? Yes, go ahead. Yeah, you can put something in the comments. Yeah, you can. So what I'm showing is the minimum that you need to put in the comments. You can add additional stuff if you want to in the comments. Yep. Not 1, 2, 3, 4, 5. It is 1, 5, 1, 3, potentially a 5, and then 6, and then the post in this case. Correct. Yep. Yeah, because some people may say, oh, okay, because if we're skipping line 2 and line 4, then I need to make sure that people understand we are falling through all the cases to line 5. So that's okay. I can understand that. But there's really nothing to do on line 5. There are no conditions to evaluate, and there are no assignment statements to change anything. So, it really doesn't do a single thing. Okay, so on line 6, what do? We use y to update z, so z gets a value of -3 in this case, and then we get to post, and we're all done. So do we have any questions about this? No, no questions? Okay, so once again, this is a spreadsheet that you have access to. The name of the spreadsheet is 2025-09-17, which means there's no need to take a picture of this screen because you actually do have access to the whole spreadsheet. Are we good so far? Okay, all right, cool. So now we're going to go back to my little agenda because if I don't come back to this page, I will not remember what else I need to talk about. Okay, so here's the new homework assignment. So let's go to the new homework assignment. Okay, and let's go there. Okay, well, it's 31 now. It was 29 like shortly before 9 a.m. So two people kind of squeezed in their submission. That's good. That's fine. So now we are going to nested control structure, with the corresponding trace assignment here. So this is the nested trace assignment. It's kind of the same format. You have the code, okay, with line numbers, and then you have to create a trace in a Google Sheets. I specify the format in details. And also this time I emphasize, to do all the editing in the Google Sheets and give me edit permission. So this way I can actually see how you edit the document, okay, for a few purposes. One purpose of me going through how you edit the document is to see if there are anything and any type of misunderstanding that is common, within the class. Then I can go over that topic again. It's like, nope, this is not how the algorithm works, okay? So by going through how you edit the document, I can tell, okay, maybe there's a misunderstanding about this concept here. And so that's helpful for me. But this also means that if I see any copy and paste directly into the whole document, I'm not going to give that submission any points. All right, so I hope that is fair enough. Yes. Or if I see something that is edited in an order that does not make sense, I can also choose not to give that submission any points. In other words, the ordering of editing has to make sense. Yep. Oh, that's perfectly fine. I can tell, I can see that somebody make a mistake, go back, change a few lines, that's not a problem. It's only when I see things that are clearly out of order, it's like no one can work on this assignment in this particular editing order, then I go like, nope, this person is getting zero. Yep, sure. You can make a new sheet if you want to. I do not want that to be in the same as the trace sheet. So you can make another sheet if you want to and just copy the algorithm into the other sheet. That's fine. I'm not going to take points off. But it does make, grading it a little bit more difficult because this trace is going to be longer than the one that was due today. Yep. All right. So make sure you give me edit permission and also make sure that you put the URL of this, document in the submission page itself. So that way I can, kind of quickly go into the document and do the grading. All right. Any other questions? No other questions? All right. So without any additional questions, I go back here, okay, because I need a reminder of what I need to do. So I'm going to give you the trace of this particular algorithm, okay, just so that we have another exercise of what do we do with nested, loops in this case. All right, so let's work on this one. But before I go any further, I probably want to get my tablet to work. So give me a second to get that configured. Okay, tablet. There we go. The reason why the tablet is useful in this case is because I want to show you how to parse the text of this particular program. In other words, how can we tell, what statement starts where and where does it end and so on. So on Monday's lecture, for those of you who either was here in person or have watched the video recording on Monday, you would remember that there are two distinct diagrams that may be necessary for some people in order to understand what is happening with this code. What is the first diagram? How do I call the first diagram? It has to do with looking at the text of the code and extracting the structure of that code. What is that diagram called? Syntax is a syntax tree. Exactly. Okay, so it's called a syntax tree because it looks like a tree. When in computer science, when we look at the tree, we don't really see the branches up. We see the root and then all the roots, underneath, the tree. But that's kind of something that you will also encounter in your other classes. So I'm not going to spend too much time to talk about what exactly is a tree in computer science. So let me turn on my screen share. It's using the correct IP address. Okay, excellent. All right. So let me start the tablet screen share. This is a super note. There we go. All right. So the first thing I'm going to do is something that you cannot see because I have to copy the code into the super note first. Okay. So as I'm copying, you won't be able to see anything, but that's okay. This won't take too long. X equal to 0. Then we have while x is less than 3. Open curly brace. Y equals x. While y is greater than 0. Y gets y minus 1, semicolon. X gets x plus 1, semicolon. Close curly brace. All right, there we go. All right, so there we have it. I intentionally did not use new lines. In other words, the original code had nice formatting with all the indentation and all the lines breaking to let you know, okay, this is the structure of the code. I intentionally make this as difficult to eyeball as possible. And why do you think I did that? Because when the code is presented like this, you cannot just use the indentation and the structure of the line to try to guess the structure of the code. You have no choice but to use BNF now. That is why I make this code as difficult to understand or as unintuitive to understand as possible so that we have to use BNF. Is that okay? So one way to use BNF is to identify at a statement level. Okay, expression level is kind of a pain, so I wouldn't do that. I would just look at the statement level. So I look at this and go like, okay, we got a statement here. And we look at this, we got a statement here. So I'm only looking at the assignment statement because they are the lowest level of statements. They cannot contain additional statements. So I'm looking at all the lowest level statements. Okay, that's a statement. This is also a statement. So all of these are A, S, G, N, S, T, M, T for assignment statements. Okay. And this entire lecture is getting recorded, which means you can actually go back and watch the video and see how I go through this entire process. All right, so with all of these recognized, then I go like, okay, so from the perspective of the computer, it will first recognize that we have an assignment statement, cool, and then it sees the word while. What kind of statement starts with the terminal while? WHILE, spelled exactly that way. It's a while statement, right? Okay. How many statement types have we talked about in this class up to this point? We have assignment statements. That's the very first kind of statement. What is the second one? Conditional statement. And then after conditional statement, we have block statements. Okay. And then after block statements, we go through the loops. But there are two kinds of loops. One is called a while loop. The other one is called a do loop. So there, so we have 5 different kinds of statements. So the question now is, if the computer sees the word while, can it differentiate amongst those 5 and say, oh, I know for sure this is going to be this kind of statement? The answer is yes, okay, because a while statement is the only one that can start with the word while. Does that make sense? So now we look at this while word here and go like, okay, if this is a while statement, what am I expecting next to it? Open paren, okay? Because the open parentheses is actually in boldface. It is a terminal that we're expecting. Yep, we got that. And then we expect a condition. Okay, so I'm just going to say this is a condition. As expected, all good. This is a close parenthesis, which is also what we expect. What goes after the close parenthesis in a while statement in BNF? A statement. Very good. Okay, it is a single statement. But instead of seeing a assignment statement, it is seeing the open brace here. So when the compiler sees the open brace and is expecting a statement, can it differentiate between, can it find exactly what kind of a statement it is expecting? Remember, we have five different kinds of statements. We have assignment statements, which starts with the name of a variable. We have conditional statements, which starts with the word conditional. If, very good. Okay, so a conditional statement starts with the word if. That doesn't look like if to me. What about block statements? What do block statements start with? The open brace. Okay, so the compiler now goes like, oh, okay, I'm expecting a statement, but I'm seeing an open brace. I must be expecting a whole block statement. That is what the compiler sees. Okay, so we go like, okay, cool. So everything from here to here is going to be the block statement. But what goes inside the block statement? Sorry? Any number of statements. So any number of any statements, which means you can have no statement whatsoever. You open the brace, you close it right away. That's actually okay. It's called an empty block. You can have a bazillion assignment statements. You can have while statements. You can have conditional statements. You can have another block statement. Okay, there's no restriction. It just says any number of statements inside the block. Okay, between the open brace and the closed brace. That is what the BNF specifies. All right. So I'm referencing everything back to BNF because the BNF is the most precise way to tell you what the computer should do with the stream. Okay, with all these text here going into the compiler, that dictates how the compiler should see the input stream. Is that okay? So understanding how to use BNF is going to help you understand how to use any programming language, not just C++, not just Java, not just JavaScript and so on, because most, if not all, programming languages can be specified using BNF. Are we good so far? All right. So now we go into here, and there's a statement here, assignment statement, which turns out to be really just a statement. And then we get to here. So what is that telling you? It's the beginning of another while statement. Very good. So we see the while, we see the open paren, we see the condition. Okay. So I'm not going to get into the details of how we parse the condition, but we see the condition. We see the close paren here. But wait, Tech, there's no open brace here. Because the next thing that the compiler sees right after the close paren is the name variable y. So what kind of a statement is that? Well, it's already on the screen. It's an assignment statement, right? But an assignment statement is really just a statement. So from the compiler's perspective, it goes like, I have all the components already, okay? Everything from here to here. These are the five components that I need to turn that whole thing into a while statement. And the while statement is really just a single statement. It is a special kind of statement, but it is just a statement. Are we good so far? All right. So what is after that? Okay. So what is after that is an assignment statement, which we already recognize, but the assignment statement is really just a statement. So now we have a statement followed by another statement, which is perfectly okay because both of these are inside, or actually the three of them, they're all inside the braces, right? Inside the block statement, exactly. Okay. So now we have the five things that we need to say, oh, this is a block statement because they all start with this brace, they all end with this brace, and then in between we have the three statements. So now we look at all these five components and go like, cool, now we have a block statement. But the block statement is really just a statement. This statement is now combined with the other four components that we came up with that we recognized already. So now all these five, okay, combine to a while statement. And that while statement is really just a statement. So this statement, so at the top level of this code, there are only two statements. The first statement is the assignment statement. The second statement is everything from here all the way to the end here at the top level. Okay, so this is called a tree or a syntax tree with um, mm, this is actually closer to the root. So you're looking at a tree upside down. Okay, these are the kind of like the finest part of the root is all the way up here. The actual singular root of the tree is actually down here. All right, so this is the process of parsing. On Monday, I went through this process with a sample program already. This is the second time that I perform a syntax tree construction, so that you guys hopefully you guys look at this and go like, oh, okay, I'm starting to understand how to apply BNF so that I can understand the structure of the program. Is that okay? So that's one aspect of understanding the code. The second aspect is, okay, now we understand the structure, but what is it really specifying? What is the behavior of the code that this is trying to specify? So that would be the second kind of diagram. Okay, we went through this also on Monday. So the second one is basically in the form of a flowchart. So we look at x equals to what again? I cannot remember. uh, 0, okay? So x equal to 0 is its own little block, okay? Because it's a statement. And then we have another statement here. So from the perspective of the flowchart, the next statement is, I'm going to give it a lot of space, but rectangles are really used here to specify, oh, okay, there's a statement here, and then the little ellipse here or circle is the terminator. It indicates, okay, this is the end of the entire program. So it's not really particularly important here. So this entire gigantic rectangle is representing the second statement of the entire algorithm, which we know is it is a while statement. This is the first statement. This is our second statement. It is a while statement. So now the question is, okay, we can see all the components of the while statements, but how is it structured in terms of the behavior? So now we go back to the flowchart, right? We go to the flowchart and then we draw the template of a while statement. A while statement always start with a diamond, okay? There's a question you need to ask. And if the answer is true, you go to one place. If the answer is false, you go to another place. So we just label the branches here. If it is true, then you have a block of stuff that you need to do. But when this block is all done, guess what? You go back to the diamond and you ask the question again. When if the question in the diamond has an answer of false, then you are all done. Okay, so it's time to exit from this entire big block here. So this is the structure of the while loop that is our second statement. I don't even bother to fill in the diamond yet because I want to understand just the structure of the code at this point. So now, what is inside this second to the largest rectangle? In the analysis here, now we are looking at the block statement. So the block statement that starts with this open brace, ending with this closed brace here, is that entire inner rectangle. So now we go to the inner rectangle and go like, okay, we got an assignment to do first, which is really usually just a smaller rectangle. And we have an assignment at the very end, which is also a smaller rectangle. What is between the two smaller rectangle is another while loop. So now you go like, oh, okay, so can do you know how to draw the template of a while loop? Okay, it has got a single entry point to a diamond. The diamond goes through into another rectangle here, right? When this rectangle is done, we go back to the diamond. So this is the true branch, and this is the false branch. When it is false, then we proceed with whatever is next to it. Are we doing okay so far? Okay. So now I can now go back and actually backfill whatever is supposed to be in the diamonds. So for this diamond, it belongs to the condition of the outer while loop. So the condition is x is less than 3. Okay, so we put x is less than 3 here. This is the first assignment statement that is inside the block statement. So we go back to here and ask, what is the first statement in the block statement? Y equals x. Okay, so y equals x goes here. Now we look at the condition of the nested while loop, which is, wrong direction. There we go. It is y is greater than 0. Okay, we put in y is greater than 0. And now we have to go into the nested while loop and find out what are we doing repetitively. Oh, wrong direction again. So that turns out to be y gets y minus 1. Okay, so now we have y gets y minus 1. And when we exit that loop, what do we do? The single statement here, which is x gets x plus 1, is outside of the while loop. So now we have x gets x plus 1. So now, not only do we know the structure of the code, we also understand the behavior of the code. It's only when you understand the behavior of the code, they can start to trace it. So do we have any questions about this process up to this point? Okay, and when people take a picture, I have to step out of the way because I don't want to be a part of that picture. Not because I'm on the most wanted list, it's just because I don't want to be up here. I don't want my picture to be taken. All right. I might be on the most wanted list, just that I don't know about it. Yes. Oh, this is the best part of this entire discussion is no, it is not. I'm assuming that you know how to do this already. So the test is about the trace, which you cannot do until you can get this. But I don't care how you get to understand the behavior of the code because different people do it differently. When I was a student, same as this class, I never relied on flowcharts. I read the code, I read the text of the program, and I know what it is supposed to do. Doing the flowchart step and also the syntax tree part is just a waste of time for me when I was a student. Now, is that true for you? I don't know. I'm not you. Okay. So for some people, going through all this process is useful because they need to go through this process. For some other people, they don't need to do this at all. So you kind of have to find out for yourself, do you need these diagrams? If you do need the diagrams, then you need to practice it enough that you can do this really quickly. And I'll give you a little um, I'm trying to think of how to describe what I'm about to say. Well, I'm just going to say it without classifying what it is. I think by the time in about 2 to 3 weeks, all of you should not need the diagrams to understand the code. Okay, this is really a crutch at the beginning of a class like this. But in the middle of this class, in a few weeks, you should be able to go straight from the text representation of the algorithm and understand the behavior of the algorithm without having to draw the diagrams. Are we good with that so far? Do you understand what I'm trying to say? Okay, all right. So that means, in the exam, and you go like, okay, I'm going to have to draw the diagrams to understand what the code is doing. You can do so, okay? You can attach additional sheets of paper if you want to with these diagrams, but the diagrams themselves will not carry points, okay? It is just kind of like scratch paper that some people may decide, okay, I kind of need this. Okay, fine, do it, okay? But I'm not going to grade the diagrams, okay? I'm going to grade based on the actual trace, which is the evidence that you know what the code is going to do. Is that okay? All right. Okay. So now that we have this diagram, we can now kind of work out the trace. So this is the part where it gets a little bit difficult because when I'm doing the trace, I can't really show the diagram. So I can do something, okay, to see if I can make it happen a little bit easier. Okay, so give me a minute here because what I want to do is to shrink the diagram and then display it kind of at a corner so you can still kind of see a smaller version of the diagram in a PIP, picture in picture, but it's not going to take up the entire space. So I'm doing a screenshot right now on the other screen that you cannot see, and open here. Let me see whether it's still too big. I think this is going to be okay. I can put it here. And then I'm going to put this whole thing back here, and I'll put it, in the same, spreadsheet that we did today. So we'll go like this is the nested loop trace, and then show the picture again like so, and make this one always on top. So this way I don't lose track of the picture when I try to do the trace. All right. So are we ready to trace it? Okay. Now this one doesn't give me the line number, so I kind of need the line numbers too. How am I gonna do that? Oh, okay. I know what to do. I can copy and paste this code into the Google Sheet and then use the row number as my line number. And I'm gonna kind of put in the actual indentation. Like so. And if someone is saying, okay, but Tech, you could have used open brace here on line 4 and put a close open brace between lines 5 and line 6, the answer is yes, but that would not be necessary because the only statement that I need to repeat in the nested loop is really just y gets y minus 1. X get x plus 1 is outside of the nested loop. It is a part of the outer loop, but it's not a part of the inner loop. So I intentionally did not put in the braces so that to emphasize the importance of understanding BNF. Because if I present this to a Python programmer, in Python, it is all based on indentation. Okay, what is nested within what else is entirely based on indentation. In C++, indentation means absolutely nothing to the compiler, to the computer. So this is actually intentional. All right, so I'm going to take a snapshot of this also. Like, there we go. And open another one and put this one down here because otherwise I don't know the line number. The flow chart does not tell me the line numbers. All right, so now we have everything that we need in order to do the trace. So another tab open over here, and I'll just call this the trace of the nested loop. There we go. So we start with the usual, okay? We have line number, and in this case, we only have two variables, one for x and one for y. And then we have comments, because we have to indicate the conditions that when we evaluate the conditions on line 2 and also on line 4. So this is the precondition. What do we need to know about x and y? The answer is nothing. We don't need to know anything about x or y because the first thing we do to x is to change it, whatever value that it had, to a 0. So any assumption about the initial value of x is pointless because it just gets changed right away. So that means we don't need to know anything about x. Same thing with y. Because before we reference the value of y on line 4, the line right before that changes the value of y, which also means if y had any assumption or assumed value, it is not of any use to me. It doesn't change the algorithm in any way, so y can also start with an unknown value in this case. We get to line 1, x gets a value of 0. We get to line 2, we evaluate the condition x is less than 3 is definitely true because x is 0 at this point. We get to line 3, y gets the value of x, which is just 0. We get to line 4, we evaluate the condition y is greater than 0. And what is the answer to that question? It is false. Very good. Okay. So now, where do we go? We go to line 6. That is correct. Okay. We go straight to line 6 without going to line 5 even once because the condition is checked right here. And if it is false the first time, we skip around y gets y minus 1 and go straight to x gets x plus 1. Okay. So this is kind of important. All right, so we get to line 6, x becomes 1, and now where do we go? Line 2, that is correct, okay? Because we have to go back to the beginning of the outer while loop, and that part is somewhat clear also, when you look at the flow chart, because we are basically done here, and then that goes, basically we are done with this entire block. The only outgoing arrow from this entire block is this arrow here, which goes all the way back to the condition of line 2. So that tells us that we have to continue on line 2. So we get to line 2, and then line 2 is going to evaluate the condition. X is less than 3 is true. We go to line 3. Now y gets a value of 1, not 0, because the value of x has changed already. Then we get to line 5. Y is greater than 0 is actually true this time. Then we go to line 5. Line 5 is decrementing the value of y from 1 down to 0. Now we get back to, now where do we go? Hmm? Nope, we are not going to line 6, okay? So in the flow chart, what is corresponding to line 5? I know it's hard for you guys to describe it, but line 5 is corresponding to y gets y minus 1, which is this block over here. So according to the arrows, where are we going to? We go back to reevaluate the condition of whether y is greater than 0 and which line does it belong to? Go back to line 4. That is correct. So we go back to line 4. Y is greater than 0 is false. Then we go to line 6. Do we have any questions about this part? Because if there's anything tricky about this trace, this is probably it. Are we good? Hmm? Sure. From which row? These are the row numbers. So which row are we referring to? This is row 10. Row 10, go back here. Okay. So row 10 is corresponding to line 4, which is corresponding to this diamond in the picture. It is asking the question, is it true or is it false that y is greater than 0? At this point, y had a value of 1. 1 is greater than 0 is true. So according to this diagram, we take the branch that is labeled true. We get to this block here, which is y gets y minus 1, and that is corresponding to line 5. So are we good? Okay. Yep. So you can see, if I really want this to be completely spelled out, there are many things you have to track, right? There's the text representation of the algorithm where it gives you the line numbers. There's the flowchart that tells you the behavior of the code, and then there's the trace, which is basically look at the trace as a roll of film. Okay, it is basically a video recording what happens when this code executes. Is that okay? All right. All right, so we can go back to line 6. Okay, so line 6 got one thing to do, which is incrementing x by 1. So x is now 2. And you can see how from this point on, it is really just awfully tedious. Okay, which is true. Okay, but I'm going to finish this. Okay, I will finish this entire trace just so that you guys know exactly what happens when this code executes. So after line 6, we get back to line 2, which is asking, is x less than 3? Yep, it is still less than 3, only by 1, but it is still less than 3. Then we go to line 3, y is now initialized to 2 because it is just copying the value of x at that time. And then we go to line 4, y is greater than 0 is true. And then this time we have to go through it a few times. On line 5, it becomes 1. Go to line 4. Yep. Y is still greater than 0 is true. We go back to line 5. Finally, y is a 0. But we don't go to line 6 right here because line 6, the only way for line 6 to proceed is to go back and ask the question again. Okay, so the trace has to reflect exactly what the computer is going to do, not what you can shortcut. Okay, so we have to go back to line 4 at this point and clearly indicate that y is greater than 0 is now false. Then we get to line 6. Line 6 is going to add 1 to x, which will bump it up to 3. Then we get back to line 2, which asks, is x less than 3? It is now false. Then we get to post, which indicates, yep, that's the end of this entire thing. Are we doing okay so far with the process of making this trace happen? We good? Okay. Does it sound awfully tedious to you? Yes. Okay. So why do I ask you to do something kind of tedious? Because this is the only way, okay? When I look at the trace that you turn in, that is the only way that I can confirm that you understand how the code is supposed to work. Okay, so that's the reason, okay? And I promise you that I will not give you, extremely tedious traces to do without a reason, okay? Most of the traces that I ask you to do is trying to have you to confirm that you understand the underlying concept of whatever I'm teaching at that point of this class. Is that okay? All right, cool. So with that done, let me go back to my little agenda here because otherwise I don't remember what I'm supposed to do. All right, so we are now done with the presentation of another example of a nested statement. So that would be just be referring to the sheet that we just worked on, which is the trace of the nested loop. This is the algorithm itself. This is the actual trace. Now, what one thing you can do, because I make this available to the whole class, and you have access to it like even now. So one thing you can potentially do, now this is up to the individual to decide whether you want to do it or not. One thing you can do is to go to File. Now you only have read access to this particular document, but one thing you can do is to make a copy. Okay, so you make a copy to your own Google Drive. Can be your school Google Drive, can be your personal Google Drive, I don't care. Then with that copy, you can annotate, you can color code, you can do whatever you want with that document. Okay, I think that is one way for you to have a starting point. And if you say, okay, but Tech did not quite explain everything in his own trace, like all the tricky transitions within the trace, you can color code it, add comments, okay, print it out, and just use paper, pen or pencil to annotate the trace. Add your own notes to it, the whole thing. Okay. Now, do you need to do it? I don't know. Okay. It is a very individual kind of thing. Some people may want to do it. Some people may need to do it. Some other people may not need to do it at all. Okay. So it's up to you. But I'm just telling you, this is another resource that is available to you. Are we good? All right. So now with that done, we are moving on to the last item here. And you can see how I struck out, this portion here and I changed it to array discussion. The reason why I am skipping pre and post condition right now, let me show you what it looks like first. Then you guys will go like, oh, okay, I see why you want to skip over that for now. Where is it? Nope, not here. Okay, let me locate it. Pre and post conditions. There we go. All right. So up to this point, it's not too bad, and then okay, refresh. I don't know why the math equations were not showing up. So now we got a whole bunch of stuff like this. Okay, it's all kind of math related stuff. So I go like, well, maybe this is a little bit too abstract at this point. I want to go over more examples so that you guys get a good handle on how code executes before we go back to this point and go like, okay, can we execute an algorithm backwards? In other words, we start with what we know on a particular row, and then we can go backwards and say, okay, if we know we got here, can we infer what is the row right before this in the trace, and then the row right before that in the trace, and so on. Okay. The reason why this is important or this topic is important is not because I just want to throw math stuff at you, okay, which I do, but it's not the reason. The reason why this is important is because this is the kind of reasoning, analysis, and critical thinking that you actually need in order to debug programs. Okay, so what is debugging? What is the term debugging referring to? What is the process that it's referring to? Say again. Fixing errors in the code. Exactly. Okay. But before you fix the error, you have to first find out where the errors are. Okay. So the first step of debugging is to find out what's wrong with this code. It's kind of like, when you wake up in the morning, and you try to drive to ARC and your car won't start. Okay. So clearly something is not right. Okay. Yes, I know some smart people will say, but Tech, I have an EV. It doesn't start like that. Fine. Okay. We're talking about internal combustion engine cars. Your car won't even turn over. Okay. But in that case, what do you do? Yes, I know some of you will say, yep, I'm smart. I'm just going to call Uber. No, assuming that you want to fix the car, what is the first step? Troubleshooting, right? So how do you troubleshoot? If your car won't start, what do you do? Yep. Well, the first thing is to see whether you even see the check engine light, right? When you turn, is there anything on the dashboard? Because if it is completely dark when you turn or when you press the start button and it's completely dark, then it tells you the fault is really high up, close to the battery, right? Because if the terminal of the battery is somehow corroded or your battery is completely discharged, okay, then you get a symptom. But if you do see the indicator on the dashboard and they're reasonably bright, okay, they're not very dim, so that means you probably still have power. Your 12-volt battery is still good. But why is the car not turning over? Well, it could be the relay connecting the electricity from the battery to your starter. So if you don't hear any clicking sound and your car doesn't go like wow, 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 wow like that means your starter may not be getting power. So now you can focus on what is between the starter and the battery. There's a whole process of troubleshooting, but you have to understand how your car operates first. Okay? It's the same thing with debugging. Okay? In order to find out what is wrong with your program, you have to understand what each kind of statement is supposed to do and what you expect the program to do. Then you have a reasonable amount of information to go debug your program. I'll tell you a funny story. It won't be very funny when you are in that situation, but it's funny because I was a TA at the time, a teaching assistant at the time. So I was a TA at UC Davis the first year I was in graduate school, and I was responsible for a class kind of like this one, except at UC Davis at the time, there were no classes like this class at the time. The first class in the entire computer science program is what we know as CISP 400. They did not have CISP 300. They did not have CISP 360. The whole program starts with CISP 400. Okay. So anyway, so I would go to the lab and students would be kind of, doing the homework assignment. Usually this happens when the assignment is due in a few hours, like the following day. When the programs do not work, I have personally witnessed this happening. The students would make random changes to the code. It's like, okay, maybe I should change this greater than to greater than or equal to. This one, maybe it should be a zero. So they will start to make these little nudges to the program, which is equivalent to you opening up the hood of your car and it's just randomly starting to pull the cables and go like, maybe this doesn't belong here. I'll plug this over here and so on. But wait, this plug is not even of the same type. It won't plug over there. Let me find something else they can plug into. Do you think that's going to help? If you're doing that to your own car, let me know when you do it because I will stay at least 1 block away from you because it is more likely to lead to more problems down the line. Okay, so that's why debugging is important because if people who do not actually use the proper procedure to do debugging, they are just making things worse when they're quote unquote debugging. All right, so now that we are skipping over this particular section, we're gonna start with array discussion. And we got about 15 minutes to do it, which is more than enough. All right, we have looked at the algorithm just today to find um, the largest or the maximum value of 3 variables. So let me go back to that section just so that we can focus on this code here. So this piece of code will help you find the largest or the maximum of 3 variables and then put the value of the maximum into variable z. Okay. So looking at this approach, do you think you can figure out how to find the maximum of 4 variables? So I'll give you v, w, x, y, and I want the maximum to be stored in variable z. So do you think you can look at this code and go like, yeah, I can see the pattern and I can make my algorithm to find the maximum of 4 variables? Are you guys feeling kind of confident about that? Should be fairly confident. We just have to kind of extend the program a little bit. Instead of confirming w is greater than or equal to x and w is greater than or equal to y, the first thing is to confirm whether v is the maximum or not. How do we confirm that? We say v is greater than or equal to w, and v is greater than or equal to w, and v is greater than or equal to x, and v is greater than or equal to y. That will confirm v is the maximum, and then we just change this code and go like z equals to v, and then we just make accordingly changes to the rest of the program. It gets a little longer, right? The condition gets a little bit bigger, but we know the approach. Are we good so far with that discussion? What if I say we have 20,000 variables? Would you still use this approach to do it? Probably not. And then someone's going to say, why would you want to find the maximum of 20,000 something? Okay, let me give you an example, and I hope that you guys will start to realize this is the reality that we are in. Okay, let's just say that we have a ranking system for job applications, and it is a local company called VSP that is hiring a software engineer, and this is this just happened. Okay, we'll assume it just happened. How many applications do you think would VSP get for a single position of a software engineer? 50,000. 50,000. Now, we are not talking about Google. We are not talking about X. We are not talking about any well known company. We are talking about VSP, which is a Sacramento based company. They do vision insurance and whatnot. They are growing, but they're still not a huge company. They get 50,000 applications. Okay. And that's last year. So when you graduate with a bachelor's degree in computer science, what will the situation look like? I cannot tell. Okay. Maybe it's going to be better because a lot of people decide not to pursue computer science. Maybe it will be worse. Okay. I cannot tell you what it's going to look like. I can only tell you what happened last year when VSP had a position. Okay. So that kind of gives you the context of why I might want to find the maximum of 50,000 numbers. Okay. So using this approach to find the maximum of 50,000 values is not scalable. In other words, can you do it? Yes. But is that a good way to do it? No. Okay. So the reason why we need to talk about arrays is with arrays, The answer is really simple. Okay, so I'll first give you the answer first, um, and then we'll kind of get into a little bit about the notation, and that'll be the end of today's lecture. So let me start with mouse pad so I can actually write the code. Okay, so this is mouse pad. So the code, if we use arrays, it will look something like this. Okay, it may not be exactly, but it will be close. So z equals to a bracket 0, while oh, I need another one. I equals to 1, while I is less than n. Do the following. We'll say if a bracket I is greater than z, do the following. I gets I plus 1, and then in here, we'll say z equals to a bracket I. So this is the algorithm to find the maximum within an array, but how many items are in the array does not really change the size of this code. So this code will work when the array only has 10 items, only 10 people apply for this job. It will also work when 100,000 people apply for that job, or a million people apply for that job. It will work regardless of the number of items in the array. So now it goes back to the question of what exactly is an array? An array is a container. Okay, so first of all, an array is a container, which means in this context, the array contains a number of values. Okay, so if it has a bunch of values, how do we say, the first value, the last value, and so on? So every value has its own quote unquote address, which is a number. So when we see this notation here, it is called array indexing. A is the name of the array. When you use square brackets or just brackets, it is called the indexing operator because whatever you specify inside the square bracket is the designator of which item in the array do you want to access this particular time. Okay, so the best way to imagine this, okay, I'm going to use the whiteboard a little bit, but since I'll be describing everything using words, I don't think it's going to be important to use a diagram to do it. Well, I still have the tablet up, so I suppose I can use the tablet and actually have it fully recorded. Okay, let's do it this way. And the tablet is sleeping, so I need to wake it up and turn screen share back on. Yep, there we go. And just do a quick refresh here. There we go. Okay, so the best way to imagine what an array is look at it as a box with multiple slots. Okay, so go back to the pen tool. So think of it as a box. And the individual item in the box, it will just say those are coffee mugs. Okay, so you have, let's say, 5 coffee mugs here inside the box. The box itself has a name. Okay, in the example that we just looked at, the name of the box is simply lowercase a. Obviously, it doesn't tell you what the box is containing, but that's just the name of the box. The individual coffee mugs inside the box, each one can have a different level of coffee. So one can be empty, which means it has a value of 0. Another one may have a value of 216. Another one may have a value of -4, and so on. So each coffee mug can have a value that is independent to the other 4 coffee mugs within the box. We good? But the coffee mugs do not have names. They are numbered instead. So the first one is numbered 0, second one is numbered 1, 2, 3, and 4. So in this case, we have an array of 5 values, and each value has a number of 0, 1, 2, 3, or 4. So if I want to specify this particular coffee mug here, its name, its full name, is A square bracket 2 close bracket. In other words, we're telling the compiler, go to the box with the name of A, and then locate the coffee mug that is labeled 2. Are we good so far? So it sounds like This is just a fancy way to name different coffee mugs instead of saying, oh, we have a coffee mug here that is called variable X and variable Y and variable Z. We just name these things with a more fancy name, which is A bracket 2, A bracket 1, and so on. Well, that is true too, but this opens up a possibility because the this notation, array indexing, what goes inside the square bracket does not have to be an integer. It can be an expression that evaluates to an integer. Is that okay? So that means if you have some other variables, you go like, oh, I want to specify a really complicated, expression here, which is I times 2, the whole thing minus 1, and then take this entire thing also, and then add a 4 to it. As long as it makes sense in the context, it's okay. So that gives you the ability to specify algorithms like the one that I just showed you. So the one that I showed you, which is this one here, you can see that the expression inside the square bracket here and also here is really just a very simple expression, which is I. But I is a variable. So depending on which iteration you're talking about, the value of I on this line and on this line are different. So that means for every iteration of this while loop, lines, okay, what is this line number? 5 and 4. So line 4 and line 5 will be referring to a different coffee mug in the box, depending on which iteration we are in. That gives the algorithm a very powerful mechanism to specify logic or how to do something. Is that okay so far? So I don't want to dig too deeply into the actual use of arrays, but I do want to make sure that we understand the importance of the concept of an array. It gives us the ability to specify a different coffee mug depending on an expression. That is the flexibility that arrays allows us to do. So the concept of an array is fundamental to most algorithms in computer science. So this is actually super duper important, okay? And the key of why this is important is because the same line, the same expression can refer to different values depending on the expression inside the square bracket. And in this case, it depends on which iteration of the loop that we are referring to. Okay, so I think that part is really important, not only the mechanism itself, but why it is important. All right. So with that said, we are done with today's lecture. Once again, if you have not watched the lecture on Monday, I certainly want to urge you to do it, okay? Unless you say, okay, I understand all the material already, it's not a problem, it's okay too. But next Monday, we'll be talking about the practice exam. So if you show up here in person, then we can have an in-person discussion of, okay, wait, hold on a second here, I'm not quite understanding that. But if you don't show up, I cannot get your questions. Yep. Hmm? Okay, so when was the test? When did I talk about the test? It is in the announcement. So if you go back to the announcement, it will tell you this is when the first exam is going to be, October 1st. Hmm? How do you access? Um, okay, yes, the recording, scroll all the way up. Do you see a link to my YouTube recording? Yep. I did not take attendance today. Yep, that's all right. Yeah. Yep. Yep. All right. So you doing okay? All right.